and talk about dilutions. Okay, and this will be the last bit that I talk about in this video. Okay, so I have a picture right here, so let's follow through it. So we first start with what we call a stock solution. And a stock solution is going to be something that's very concentrated, okay? So like, for example, if you like to make orange juice using those frozen, like, you know, those little tiny frozen juice things, right? And then you put it into water and you bring up the volume of water to like a gallon or something, that would be your stock. Or like, for example, if you make some super concentrated Kool-Aid, like way too concentrated, it's way too sweet, that would be like your stock solution. So your stock solution is often provided to you by a manufacturer or some chemical company or some stock room, literally a stock room, because for those manufacturers or stock rooms or companies, it's easier to give you a more concentrated solution. But perhaps you want to use a more diluted version of that. So here's what you would do. You would extract some volume. Suppose you would extract 25 mils. Okay? You transfer it to a new container. So now you've got 25.0 mils of your stock solution. Then you would add water or whatever the other solvent was. In this case, we've only been talking about water as a solvent, but we could use alcohol as a solvent. We could use oil as a solvent, okay? There's a number of things we could use as solvents. Mostly in this class, we're just going to be talking about water, though. So now we would take this stuff. This would be our solvent, and it has to be the same solvent that was in the stock solution. And we would bring the volume all the way up. And look at this. It's saying now it's bringing the volume all the way up to 250 milliliters. So we would have diluted this stock solution by a lot. Okay, and I'll get into that quantitative amount in a moment. Okay, and so now what are the new concentrations? Or what is the new concentration? Okay, so here, so this is giving you like a run through of this. I'm going to switch over to this formula right here, the famous M1 V1 equals M2 V2. So yes, that's molarity of the stock solution times the volume of the stock solution. And now this is going to give me the new molarity of the dilute solution as well as the volume of the new dilute solution. M1V1 equals M2V2. And if you think about this for a moment, I'll write this up here in the lines. We know molarity is mole per liter times liters. And we also know this is molarity over liters times liters. So in other words, the liter and the liter cancels, and the liter and the liter cancels. And what's important to note about dilution, it ends up being mole equals mole. So in other words, when you make a dilution, you don't change the number of moles. You're only changing the volume, or in other words, the concentration. Okay? So for example, if we work through this example, and let's just say, suppose that this was, I'm just going to say, suppose this was 1.00 molar for our stock solution. Okay? And we do this thing where we go 225 mils of the stock solution diluted up to 250 mils of the new volume of the new dilute solution. Okay? What's going to be the new concentration? So here's how we can do this. So we've got M1V1 equals M2V2. So my M1 would be 1.00 mole per liter. So as it turns out, we don't have to make this volume into liters as long as both of these volumes on this side are in the same unit, milliliters and milliliters. Okay, so that's all good. So I'm going to actually just, instead of writing moles per liter, I'm going to just write molarity. And again, as long as both of these volumes are in the same unit, so V1 and V2, as long as they're the same unit, that's okay. It doesn't have to be liters or gallons or whatever, as long as they're both the same. All right. So V1 here was 25.0 milliliters. M2, we don't know what that is. We're trying to figure out, if this was originally 1 molar and I took 25 milliliters of it and then diluted it up to 250 total milliliters, what's the new concentration? So now I know my V2 has to be 250.0 milliliters, and I can solve for M2 by doing the algebra. So I'm going to divide by 250 milliliters over this side, and I'm going to divide by 250.0 milliliters over this side. So we know all of that cancels. And look what happens to the units. The milliliter and the milliliter cancel. So I'm going to get to my molarity unit anyways. Okay. And so those of you that are good with math might have guessed this, but you can see we're diluting it by a factor of 10. Okay. So 25.0 divided by 250, okay, gives me 0.1, and times the 1 molar, yep, you guessed it. M2 is now 0.1, so 3 sig fig, 0.0 molar, okay? So those of you that are good, that can see the kind of math in your head, you might have recognized off the bat right away, we diluted it by a factor of 2, or by a factor of 10. But now, you might not always have these nice whole numbers, 10 or 2 or 5 or whatever. So this is where you want to use M1V1 equals M2V2 to calculate dilutions. Okay. And so now let's see. So here's another example problem. What volume of 16 molar sulfuric acid must be used to prepare 1.5 liters of a 0.10 molar solution? I'm just going to give you the answer. See if you can work it out. Okay, and the answer is what volume, so this I'll just tell you is our stock, the 16 molar, and now we're asking, so if I would call that M1, so what volume of this, so that's V1, that's what it's asking us for. It's asking us for V1, okay? Used to prepare 1.5 liters of a 0.1 molar sulfuric acid solution. So this 1.5 liters is going to be V2, and the 0.1 molar is going to be M2. So see if you can solve for V1. I'll tell you the answer is 9.4 milliliters. Okay, see if you can come up to that answer. I'm going to move forward.